AppSec Tutorials, Cross-Site Scripting. About this course. Cross-site scripting is a method by which an attacker can use a web application to force a client-side script to run in the browser of another user. To get the most out of this course, we recommend that you take the Introduction to Web Application Security course and the Secure Coding with OWASP Top 10 Validation and Encoding course for either Java or .NET. Upon completion of this course, you will be able to describe how a hacker might perform a cross-site scripting attack and be able to identify and remediate this weakness at the code level. Hello, my name is Kevin Richard, and I'm a security researcher with Veracode. Today, I'd like to demonstrate the steps that an attacker might take to perform a simple cross-site scripting attack. The application that I'll use in this example is a .NET MVC app called Veracode.net. The HTML5 code of its front end includes several pages that use the raw control to display and enable raw HTML to the end user. Soon, you'll see why this control belongs within a group that needs to be handled with care to prevent the threat of cross-site scripting. I'll show you how an attacker could find an XSS flaw hidden within this application. The attacker logs in and begins to search for so-called threat vectors, or locations in the code that would process input data in a way that would trigger XSS. Their search leads them to the review page. Pages like these commonly contain a set of text fields that permit HTML for links or stylized input text. The application expects to receive input that looks something like this: a satisfied review that might contain bold or other HTML tags. If we edit the text to include some tags, once it's submitted, it appears that the HTML itself is displayed back to the user. This is because the page has correctly encoded the HTML, preventing it from functioning as markup. You can see the HTML characters, but the markup itself will not be applied to the data. Now, let's navigate to the basic cross-site scripting page under Security Labs. Here, if we include any HTML tags, we will actually see them rendered inside the view. For the attacker, this is great news. Whenever they see that HTML is rendered on a page, it means that it's a good place for them to begin testing for cross-site scripting. The attacker begins by typing a simple alert into the field. Just as we saw before, it is not rendered on this page. However, let's look back at the widget page, where scripts had not been properly encoded. Now it is clear that the payload has been executed, because the text "Hi" appears on the page. On its own, the ability to pop a text message doesn't seem very troubling. But remember, we did it with JavaScript. The language affords us control of a large number of things that we can manipulate in the browser, so that alert box only reminds us that we haven't seen the worst of it. To prove it, let's go ahead and direct this user to an external website. This time we'll be merciful and only direct them to Google, but it's still enough to demonstrate the amount of control that we now wield over the user's browser experience. We save our widget and return to the page that actually runs the JavaScript payload. We're immediately redirected to an external site. Again, this site didn't have to be Google. It could have been a site owned by the attacker themselves. It could have also been a background request, since the attacker can collect information about the documents and cookie and send it to themselves this way. To summarize, cross-site scripting is a technique that attackers use to take control of a user's browser. It can be used to direct users to external websites, share or steal session information, or to send background requests. And since web applications are often connected to back-end systems, it could also be used to escalate privilege when attacking a network as a whole. To learn more about advanced payloads and attacks, as well as how to prevent cross-site scripting, please continue to watch our training videos or participate in our training courses. This has been Kevin Richard from Veracode. Thank you very much for watching. If a valid cross-site scripting flaw has been detected in your application, the next step is to update your code in order to remediate it. Click on any tab to see how to secure your code from the threat of a cross-site scripting attack. Hello and welcome back. This is Kevin Richard, Security Consultant at Veracode. I'm here to give a brief demonstration of how to remediate an existing cross-site scripting attack inside of a .NET MVC application. We'll be using the VeriInsecure.net web application in order to demonstrate both the current cross-site scripting attack as well as an appropriate remediation for this attack. Once we get logged into the application, we need to get familiar with the attack itself and identify which user interface is not properly encoding the output and is therefore vulnerable to a cross-site scripting attack. It shouldn't take us long to see that the reviews displayed within the basic cross-site scripting laboratory contain HTML markup that is actually displayed to the end user. We want to go a step further and ensure that this can actually be exploited. In order to do so, we change the text that contains markup that would be displayed to the end user to include script tags. When we include script tags and then return to the actual cross-site scripting lab interface, let's see if our payload was executed on the page or if it was properly encoded. When we return to the page and we search for widgets, we do see that our payload is executed, and we can safely know that the text field of the review is not properly encoded. Part of the reason this occurs is because we are using the HTML raw control inside of our CS_HTML file. Many of the Microsoft controls are going to actually contain, within the control itself, proper encoding. However, we want to be able to display some HTML, but in a secure manner. This presents a problem. In order to support some HTML, but only the HTML that we want to allow on the page, we're going to properly encode the property in its entirety. So the first thing we'll do is completely encode the text property of the review. Following that, we're going to selectively decode the specific tags that we want to allow. So what you can see here is that we take server.html encode on the entire text property. Then we selectively take the tags that we want to support and we decode them to the HTML. In the very first replace, you can see we take the encoded h1 HTML string and we replace it with the decoded or standard HTML or h1 tag. Effectively, this creates a whitelist in which we are only allowing selective tags. Again, this is a very simplistic example of how to support specific tags. But it does support the point that you want to encode or sanitize all of your output to your end user, and then only selectively allow specific characters that you wish to have the end user provide to you, and then display and render to your end users. When we navigate to the formerly vulnerable interface, we can see the script alert tag payload is no longer executed, but rather displayed in an HTML encoded fashion, where the end user sees the original script, but the script itself is not actually executed on the page. To ensure the functionality is working as we designed, we're going to go back, include the tags that we want to support, specifically bold and italic tags, and then return to our widget page to see if it is rendered as we've designed. Here, you can see this is working now as desired. This was a brief demonstration of using a standard encoder inside a .NET MVC web application. For more information about advanced cross-site scripting exploits or other attacks, please watch some of our other training videos or attend one of our instructor-led training courses. This has been Kevin Richard at Veracode. Thank you very much for watching. Hello, this is Kevin Richard, a security researcher with Veracode. I'm here to offer a quick demonstration of how to remediate a simple cross-site scripting flaw. We'll be using the Vera Insecure Java web application and the OWASP Java HTML sanitizer in order to address this issue. Let's recap what we learned in the last video. If we return to our fake store and bring up the existing reviews, we can already see the review that contains a cross-site scripting payload inside of it. This output is properly escaped on the page, and therefore we see the script displayed on the page, but the actual script attack and payload are not executed. Now, if we visit the basic cross-site scripting lab, we see that when we load the page does not escape the script tags, and the payload is executed, causing a pop-up that reveals the attack was successful. Let's bring up the IDE to view the code that this attack targeted. I'm using Spring Tool Suite, a version of Eclipse. As I mentioned, we're also going to use the OWASP Java HTML Sanitizer project. This open source library leverages a policy to define which HTML controls should be allowed and which should not. We're going to be using a slightly altered /dot policy, altered to allow specific HTML elements that I choose. I want to allow h1, h2, and h3, so I added those to the list of allowed elements. Notice how after the policies are defined, I can apply a policy to any given text, and the text will be sanitized. So if the text contains HTML, as our payload did, a policy sanitization method that is returned from the HTML will be appropriately defined or sanitized, and then the only exception to that will be the list of allowed tags that we defined within the policy. Now let's make sure the project runs as we are expecting. Let's go ahead and go back to our review page and find the review that we are interested in. We'll edit the review to include some of the elements that should be supported by the policy. Here's our really bad stuff review, now that we have included some HTML, which should be supported according to the policy within the review. Once we save the review and return to the page that is intended to display HTML contained within the review, we would expect to see that the review itself will be displayed and rendered. Here we can see that we have proper HTML support. We want to be sure we're doing this in a secure manner, and that the previous payload is no longer effective and rendered on the page. We add our payload back in, and when we navigate to the cross-site scripting laboratory page, which was previously rendering the attack and therefore executing the Java payload, we now see that the attack has actually been removed per the policy that we defined within the HTML Java sanitizer. This was just a brief demonstration of how to remediate a cross-site scripting exploit using the Java HTML sanitizer. For more information about advanced cross-site scripting exploits or other attacks, please watch some of our other training videos or attend one of our instructor-led training courses. This has been Kevin Richard at Veracode. Thank you very much for watching. The scope of this course was not intended to cover every possible circumstance in which a cross-site scripting attack could arise. Rather, it was designed to convey the basic idea of this flaw. Further information is available through the following links. Thank you for viewing this AppSec tutorial on cross-site scripting.